Good day. So today I'll be discussing about a C program that manages sale records. This program lets us enter, display, sort, search, and edit sales records. Define max records is the maximum number of products we can store in this code. We have 20. Max product is the maximum length of a product's name. In this code we have 100 characters. So this sales data type is a custom structure designed to store and organize information about a product sales. It includes several fields to capture key details, ID, an integer that uniquely identifies the product, a string up to 100 characters that holds the product's name and sales, which represents the sales amounts for specific months like January, March, April, May, June, stored as floating point numbers to accommodate decimal values. So these are declarations of the functions we'll use later. So these variables are used to manage and control the flow of the program effectively. The records array is the primary storage that can hold up to max records number of product entries, each represented by the sales prod structure. The count variable keeps track of how many records are currently stored in the array, ensuring that new entries do not exceed the array's limit. The isSorted flag is used to monitor whether the records have been sorted by their IDs, where 0 means unsorted and 1 means sorted, which is essential for performing binary searches. Lastly, choice ID and results are utility variables. Choice captures the user's menu selection. ID is used to input the product ID for operations like searching or editing, and result holds the outcome of a search operation, indicating whether the product was found and its position in the array. So this program menu serves as the user interface for navigating the various features and functionalities of the system. It displays lists of numbered options, each corresponding to a specific operation such as entering records, displaying records, sorting data, searching for a product by ID, editing a record, or exiting the program. The user is prompted to select one of these options by entering the corresponding number. This input is then stored in the choice variable, which is used to determine the flow of the program by executing the appropriate function of displaying the relevant output based on the user's selection. So case 1 calls and enter records to input new product details. After adding records, mark them as unsorted by setting isSorted equals to 0. So case 2 displays all stored records by using display records. Case 3 sort records by ID using sort records. Marks the records as sorted isSorted is equal to 1. So case 4 searches for a product by ID. If records aren't sorted, it shows an error message. If sorted, it asks for the ID and searches using binary search. Case 5 edits an existing record using edit record. Case 6 exits the program, handles invalid menu inputs. Before adding new records to the array, the program ensures that there is enough space to store them. By checking if the current number of records count has reached the maximum allowed limit, max records if the array is full, a message is displayed to inform the user that no more records can be added, and the function exits without making any changes. This safeguard prevents data from exiting the allocated memory for the array, avoiding potential errors or crashes. By implementing this check, the program maintains data integrity and ensures proper resource management while handling product records. So this one. This program first checks if there are any records stored in the array before attempting to display them. If no records are present, it outputs a message informing the user that there are no records to display. However, if records exist, the program formats and prints them neatly in a table layout showing details such as the product ID, name, and sales figures for specific months. This structured output allows the user to view all stored records a glance, making the data easier to understand and analyze. This program organizes the records in ascending order of their IDs using the bubble sort algorithm. This sorting method works by repeatedly comparing adjacent elements in the records array if the ID of a record is greater than the ID of the next record. The two records are swapped. This process continues through the array multiple times until all the records are sorted. Bubble sort ensures that the largest unsorted ID bubbles up to its correct position during each pass, while simple and easy to implement. This sorting technique is particularly effective for small datasets like the one in this program, ensuring the records are properly ordered for efficient and searching and viewing. This program efficient searches for product by its ID using the binary search algorithm, which requires the array to be sorted beforehand. Binary search works repeatedly, dividing the search range in half. Starting with the entire array, it compares the target ID with the ID of the middle record. If the target ID matches the middle record, the search is successful, and the record is found if the target ID is smaller. The search continues in the left half of the array. If it's larger, it moves to the right half. This process repeats until the target is found or the range is empty. Binary search significantly reduces the number of comparisons needed, making it faster and more efficient than linear search, especially for larger datasets. So this program allows editing a product's details by first searching for a record using its ID, and if found, the prompts the user to update the product information. So lastly, the program processes and prompts the user to press any key before continuing, ensuring that the user has time to read the output before returning to the main menu. So let's run the program.